It's happening right now. 3i Atlas has passed behind the Sun. For the first time since its discovery, no telescope on Earth has a direct line of sight to the object. The perihelion phase, predicted for 11:42 UTC, has begun, and the data feed from several monitoring observatories has gone quiet almost simultaneously. Early this morning, infrared arrays in Hawaii detected a final surge in luminosity, an abrupt brightening of nearly 22% before contact was lost. The signal pattern wasn't consistent with a flare or normal outgassing. It carried a sharp spectral edge, the kind seen in engineered light sources rather than thermal emissions. Within minutes, solar interference drowned the reading entirely. Since then, every major telescope network, from the Very Large Telescope in Chile to the James Webb Observatory at L2, has reported temporary blind zones or corrupted data frames near the object's coordinates. Agencies are calling this expected solar interference. But the timing, down to the minute, aligns with what independent analysts warned might be a maneuver window, the moment when 3i Atlas and the 9 reported companions disappear behind the Sun together. As of 14 UTC, no reflected signal, no dust plume, and no debris trail have been confirmed. It is as if the entire formation simply stepped out of view. Governments remain silent. The European Space Agency issued a 2-sentence statement describing nominal perihelion parameters. NASA's Jet Propulsion Laboratory deferred comment until post-conjunction data recovery. Meanwhile, private radar arrays continue to sweep the region, searching for any outbound vector once the object emerges on the far side in early December. For months we've followed this object, its trajectory, its impossible stability, the unexplained energy signatures. Now it's entered the only place where no one can watch. What happens in the next 48 hours will determine whether the story of 3i Atlas ends as a natural enigma or begins as something engineered. This is October 29th, 2025, the day the Sun hides the most mysterious visitor our system has ever received. Let's go through what we know, what we lost, and what might be waiting when it comes back into view. For the first time since its discovery, 3i Atlas cannot be seen. Every telescope capable of tracking it has entered what astronomers call solar conjunction blackout, a period when the Sun's glare overwhelms sensors and communications. Normally this phase is routine. Spacecraft enter it, comets pass through it, and data resumes days later. But this time, the blackout arrived under a cloud of unresolved anomalies. The final pre-conjunction readings came in at 11:42 UTC. Both NASA's Infrared Telescope facility in Hawaii and the European Southern Observatory in Chile recorded a brief coordinated surge in brightness, a pulse lasting only seconds, before total signal loss. Instruments confirmed that the spike wasn't consistent with normal outgassing. There was no corresponding dust plume, no increase in the coma. It looked more like a controlled flash than a natural flare. Then, everything went dark. In previous weeks, 3i Atlas was already an outlier. Its trajectory was hyperbolic but unnaturally stable, its rotation steady even as solar heating increased. 9 smaller objects, first reported in mid-September, appeared to match its speed and orientation perfectly, an impossible configuration for random fragments. Together they moved as if bound by invisible tethers, maintaining precise spacing while approaching the Sun at nearly 68 kilometers per second. That formation now lies directly behind the solar disk. The silence has left researchers divided. At Caltech's Minor Planet Center, analysts argue that the blackout is entirely expected. Data transmission near perihelion is notoriously unreliable. But within independent observatory circles, the tone is different. Private spectrographs in South America, still scanning the solar limb, report narrow-band interference signals not attributable to the Sun. Nothing conclusive, just static bursts in a pattern that repeats every 47 seconds. Coincidence, perhaps, or something operating beyond line of sight. Space agencies have gone quiet. The European Space Agency released only a single sentence. Observations of 3i Atlas are temporarily suspended during conjunction. NASA's Jet Propulsion Laboratory postponed its briefing, citing the need to analyze anomalous radiometric returns. Even the Galileo project team, usually vocal online, has refrained from comment. Across scientific channels, the flow of updates has stopped. For now, all that remains is the data gathered in the final 24 hours before the blackout, hours in which something appeared to change. The Nine Companions' infrared signatures grew stronger relative to the main body, suggesting internal heat generation rather than reflected sunlight. At the same time, radar backscatter from the main object weakened, as if its surface composition shifted or its cross-section reduced. None of these changes fit known models of cometary behaviour. Astronomers call this period the blind arc. It lasts roughly 2 days for an object this close to the Sun. After that, 3I Atlas should re-emerge on the opposite side, moving away from perihelion. If it appears precisely where orbital mechanics predict, the anomalies might be explained as observational noise. But if the trajectory deviates even slightly, if the object emerges early, late, or at an unexpected angle, it will mean that some form of non-gravitational force acted on it during conjunction. And that is the crux of the tension tonight. No one can observe, no one can measure. For 48 hours, the object exists in silence, unreachable, unconfirmed, unseen. Yet the last data points before disappearance suggest activity rather than decay. Energy increasing, not fading. Alignment holding, not drifting. As one astrophysicist wrote anonymously this morning, the problem isn't what we can't see, it's what we saw right before it vanished. The world waits for the sun to turn and reveal what's left, or what's changed. Until then, the silence itself becomes the message, and that silence is louder than anything else in the sky. At 11:41:56 UTC, a final pulse appeared in the data stream from the Gemini South Observatory. It lasted only 4 seconds, sharp, coherent, narrowband. The signal wasn't random noise or a standard thermal flare. Its frequency peak stood out precisely at 1420 MHz, the hydrogen line used for deep space communications and radio astronomy calibration. Then it vanished. A heartbeat later, the main telemetry feed collapsed under solar interference, and the object was gone. That final moment, recorded simultaneously by 3 facilities, became the anchor point for every analysis now unfolding. What happened in those 4 seconds has divided the global science community. To some, it was an artifact of solar plasma scattering. To others, it was an intentional broadcast timed to perihelion. The coincidence is impossible to ignore. The signal appeared exactly when 3I Atlas and its 9 companions crossed the solar limb from Earth's perspective, entering the Sun's blinding corona. For a natural object, the odds of such perfect synchronization are vanishingly small. In the hours that followed, scattered monitoring stations across the southern hemisphere reported flickers of secondary noise. Amateur radio arrays in Argentina, South Africa, and Western Australia detected faint harmonics drifting upward in frequency, almost like an echo. These weren't official detections, they lacked calibration, control, or peer verification. Yet the timing lined up to the minute with the blackout phase. Nothing conclusive, but enough to keep professionals awake. Inside NASA's Planetary Defense Coordination Office, emergency analysis protocols went active. A cross-disciplinary team began parsing raw data from the Deep Space Network, searching for reflected radar signatures that might reveal where the object would re-emerge. So far, the models hold steady, predicted exit coordinates just beyond the Sun's western limb around December 6th. But if the object altered velocity by even 0.5% during conjunction, that emergence point could shift millions of kilometers. For an interstellar body moving at nearly 68 kilometers per second, even a minute thrust could rewrite its orbit entirely. Meanwhile, in Boston, Avi Loeb's Galileo project team uploaded a public notice acknowledging the perihelion blackout. The message was brief. All current data consistent with observational uncertainty, awaiting post-conjunction reacquisition. Behind the measured tone, internal correspondence leaked within hours. Researchers debated whether the 1420 MHz pulse was a calibration artifact or a potential emission event. One line, later verified, reads simply, "If artificial, it chose the one frequency we'd all notice." Elsewhere, the tone was more restrained. At Caltech, orbital mechanics specialists argue that any apparent coordination among the 9 companions could still stem from a fragmentation event. The fragments, sharing the parent's velocity vector, would appear to move in formation until differing solar pressures gradually scattered them. The problem? Those fragments never separated. Even in the final pre-blackout frames, their spacing remained precise, kilometre-scale alignment across tens of thousands of kilometres of travel. Natural debris doesn't behave like that. The debate now centres on energy. Earlier infrared readings suggested each companion emitted power on the order of 20 gigawatts, implausible for inert rock. Yet the math behind those estimates relies on uncertain albedo and temperature assumptions. If the object's surfaces were unusually reflective or composed of exotic ices, apparent power output could be overstated by orders of magnitude. Still, some physicists find the consistency across instruments hard to dismiss. As one analyst noted, different telescopes, same readings. That's either universal error or universal signal. Behind the public calm, quiet mobilization continues. Tracking stations normally devoted to asteroid defense drills have been reassigned. The US Space Force confirmed additional radar windows dedicated to the object's projected exit point. China's CNSA extended operational hours at its Yuanwang tracking ships. Officially, these are standard coordination measures. Unofficially, they reflect growing unease about what might appear once 3i Atlas clears the sun's glare. Historically, comets approaching perihelion brighten, fragment, or fade. They don't disappear cleanly. The absence of a dust trail behind 3i Atlas is striking. Even at extreme temperatures, no measurable outflow was observed. No vapor jets, no dispersing tail. If the object were shedding material, we would detect sodium or water lines in the spectrum. Instead, the spectrum flattened, its brightness steady until the final pulse. Whatever 3i Atlas is, it's either more stable than any comet on record or something else entirely. For now, scientists rely on models rather than images. Simulation clusters at JPL and the European Space Operations Centre run constant permutations, varying mass, spin and composition to predict post-perihelion behaviour. Every model still yields the same outcome. The object should survive the solar pass intact. But no model explains the energy readings or the companion formation. That uncertainty is why this silence feels heavier than usual. Tonight, the world looks toward a sun that hides more than it reveals. Somewhere behind that incandescent wall, 10 unidentified bodies race through plasma dense enough to destroy metal. If they emerge unchanged, we'll call it endurance. If they emerge rearranged, we'll call it intent. Either way, when the first signal returns from the far side, astronomy will record not just data points, but a before and after in how we understand interstellar visitors. For now, the last thing Earth heard from 3i Atlas was a whisper at the hydrogen line, then nothing. That silence is the story, and it's only just begun. In the absence of live visuals, the entire investigation has turned to archived data. The final 60 hours of observation before blackout. Frame by frame, pixel by pixel, analysts are reconstructing what the sky saw when 3i Atlas still reflected sunlight. The footage looks almost motionless at first, a dim green streak against deep space black, but when the contrast is pushed and the frames are overlaid, the formation becomes unmistakable. 9 compact points, each holding a fixed distance from the primary body. No drift, no dispersion, no rotation. The geometry of control. The first confirmation came from the Very Large Telescope in Chile. Using adaptive optics, researchers measured microvariations in brightness that revealed a rhythmic pattern, each companion brightening and dimming in sequence, every 7 minutes, 49 seconds apart. That timing is far too regular for tumbling debris. When the same pulse sequence appeared in images from Gemini North in Hawaii and the Keck infrared array, cross-checking removed nearly all chance of coincidence. What looked like flicker was synchronization. Data engineers at the European Southern Observatory began plotting separation ratios. The results stunned even skeptics. Every companion's distance from the primary matched a Fibonacci progression within 0.5%. In natural systems, that sequence shows up in orbital resonances and spiral galaxies, but only as emergent, not perfect order. Here, it was exact, as if designed. If that geometry holds true once the object re-emerges, it will be the first recorded instance of non-gravitational formation maintenance beyond the solar system. Skeptics argue that the symmetry could still be an artifact. When faint sources are deconvolved near bright ones, software can create phantom alignments. The counterpoint, 4 separate instruments operating in different wavelengths, reported identical spacing. The likelihood of identical software artifacts across independent pipelines is practically nil. The pattern matters because of what it implies. A symmetrical formation around a central mass means interaction, magnetic, mechanical, or directed propulsion. There's no sign of dust bridges or tidal shearing, so gravity alone can't bind the cluster. If each companion is truly maintaining its station at 68 kilometers per second while accelerating around the Sun, it would require coordinated thrust corrections accurate to centimeters per second. For comets, that precision is impossible. For technology, it's routine. At Harvard, the Galileo project's dynamic simulation team modelled what such control would require. Their estimate, continuous micro-impulses delivering only a few newtons each, perfectly phased across all bodies. The energy budget fits roughly with the reported 20 gigawatt thermal emissions, enough to power such adjustments without exhausting material reserves. But that model assumes systems designed for navigation, not evaporation. Still, the possibility of coordinated movement doesn't make 3i Atlas an alien craft, it makes it an anomaly. Nature has surprised us before. Oumuamua's acceleration once seemed impossible until subtle outgassing provided a partial answer, but the similarities stop there. Oumuamua tumbled chaotically. 3i Atlas rotates with clockwork precision. Oumuamua dimmed unpredictably. 3i Atlas brightens on a schedule. Each layer of comparison erases the comfort of precedent. In data centers around the world, scientists are now replaying the last clean minutes before the Sun claimed the view. They're not looking for spectacular images, just drift. Any sign that the companions wavered in formation. So far, none has been found. Every trajectory remains locked, every separation constant. The cluster moved as one, right until the light disappeared. And that leads to a deeper question. If 3i Atlas truly maintains structural alignment through perihelion, what happens when it reemerges? Will the formation remain intact, or will it disperse as natural fragments should under solar stress? If the geometry returns unchanged, the conclusion will be unavoidable, that some active system preserved it through temperatures exceeding 500 degrees Celsius and radiation flux thousands of times greater than Earth's. Governments and agencies are preparing for both outcomes. NASA has already scheduled the first post-conjunction tracking windows using the Solar Terrestrial Relations Observatory probes, positioned off-axis from Earth. Those probes might regain partial contact weeks earlier than ground telescopes, giving the world its first hint of what survived. A single reflection, a single trajectory ping will tell the story. If the vectors match predictions, the event will fold back into known physics. If they don't, every model of interstellar behavior will need rewriting. For now, the formation data sits locked inside servers, frozen in the hours before silence. Analysts describe it as eerie to watch, the object gliding toward the Sun while its companions trace perfect arcs beside it, like an ancient pattern repeating through plasma. Then, abruptly, the frames end. The last image captures a faint glint on the leading hemisphere, a momentary flash, and blackness. No one knows whether that flash was reflection or ignition. No one will know until December. But the geometry it left behind remains undeniable. 10 bodies, one path, one impossible order. In the language of observation, that's called correlation. In the language of curiosity, it's called a question we can't yet answer. And right now, that question is crossing behind the Sun. In the hours following perihelion, as Earth's view remained cut off by the Sun, deep space instruments operating far beyond our planet's orbit began picking up unusual noise. The Solar and Heliospheric Observatory, SOHO, positioned at the L1 point, recorded a short burst of ultraviolet radiation just after the expected time of maximum solar proximity. It was subtle, barely above background solar activity, but its spectral profile did not match a solar flare. Instead, it had a narrower wavelength band and an oddly symmetrical pulse shape, as though it originated from a single, directional source. Analysts at NASA's Goddard Space Flight Center cross-referenced the timestamp with the known trajectory of 3i Atlas. The overlap was near perfect. The emission occurred exactly when the object should have been closest to the Sun's corona. Normally, a comet at that range would erupt into a chaotic plume of ions and debris, but the SOHO imagery showed no outward burst, only a flash, then nothing. If 3i Atlas had fragmented, sensors would detect an expanding halo of dust. Yet all readings returned clean. No debris trail, no expansion, no residue. That clean absence is what troubles researchers most. Every natural model predicts chaos at perihelion, not precision. The object should have boiled, fractured, or vaporized. Instead, its radiometric signature suggested a sudden surge of controlled energy, like a system bracing against the solar flux rather than succumbing to it. For planetary scientists, that interpretation feels almost heretical. but for those following the data, it fits the pattern too neatly to dismiss. Hours later, the Parker Solar Probe, already within 0.3 astronomical units of the Sun, detected electromagnetic interference near its telemetry band. The disturbance repeated at regular intervals of exactly 1,420 MHz, the same hydrogen line frequency that had surfaced in the pre-blackout signal. Engineers initially flagged it as crosstalk from terrestrial sources, but the probe was far beyond Earth's radio reach at that point. The pattern was faint, almost lost within the roar of solar plasma, yet unmistakably structured. Each pulse carried the same separation gap, 47 seconds. The coincidence was enough to reopen quiet conversations within the Galileo Project and SETI circles. If the 1420 MHz tone appeared both before and after perihelion, it suggested deliberate continuity, a transmission bracketed around the period when the object was invisible. That possibility sits halfway between physics and speculation. For some, it hints at signalling. For others, it represents an artifact of instrumental resonance. But no one can yet explain how a consistent signal could persist through the Sun's ionized barrier unless generated enormous power or from beyond the solar limb itself. Meanwhile, energy budgets are being recalculated. Based on the last verified infrared data, each of the 9 companion objects appeared to maintain constant internal temperature even as solar intensity quadrupled. No known volatile compound can sustain that stability. Cometary cores heat unevenly, develop jets, and lose mass rapidly. These did not. The models that fit this behavior require continuous internal power regulation, something akin to thermal control. And that raises the question scientists prefer not to voice aloud. Are we observing material physics or mechanism? Official statements continue to tread carefully. NASA's Planetary Science Division described the event as anomalous, but likely natural, promising a formal report once post-conjunction tracking resumes. The European Space Agency released raw SOHO frames with no interpretation, leaving independent researchers to extract their own readings. But leaked communications from within JPL suggest mounting tension. One memo notes, if the trajectory deviates by more than 0.02 astronomical units on reappearance, artificial acceleration cannot be ruled out. In parallel, private observatories are watching the solar perimeter for reemergence indicators, tiny changes in brightness that might signal motion behind the corona. Thus far, nothing. But data from the Indian space research organization's Aditya L1 satellite, which monitors solar radiation from a slightly different angle, shows a faint dip in the extreme UV range, recurring every 8 minutes. It's not enough to draw conclusions, yet the timing curiously matches the rotation period inferred from earlier observations of 3I Atlas. If these modulations hold, they could represent the object's thermal signature bleeding through the Sun's edge. The amplitude remains constant, suggesting resilience under heat that should destroy any volatile-rich nucleus. The energy required to maintain such stability would exceed that of a small asteroid's total mass converted into outgassing. That leaves 2 explanations: unknown material properties or an internal energy source. The implications ripple beyond astrophysics. If the perihelion event confirms controlled energy release, 3I Atlas becomes the first recorded example of a non-natural energy system operating in interstellar space. Even a faint hint of that possibility has triggered quiet contingency planning. Defense coordination networks are running spectral comparison drills, ensuring that no terrestrial or near-Earth systems are mistaken for returning signals. Within SETI's encrypted working groups, researchers have been instructed to isolate the 1,420 MHz data and avoid public release until corroborated. No one uses the word contact, not yet. But the vocabulary has shifted. Where early reports spoke of activity, internal memos now refer to output. The language of geology gives way to the language of engineering. Scientists are cautious, rigor demands skepticism, but the private tone in their correspondence reveals unease. Too many patterns align, too many signals repeat. The silence since the 29th is not the empty kind that follows an observation gap. It's the strategic quiet of institutions processing information they cannot yet explain. The next opportunity to detect 3I Atlas comes when it clears the solar limb in December. Until then, the question stands like an equation waiting for balance. If energy cannot be created or destroyed, where did this energy come from, and why was it released only when the world couldn't see? As of tonight, all we have is the residue of a pulse, the trace of structured frequency, and a line of numbers that shouldn't exist. The event may prove natural, or it may redefine what we consider possible. But either way, the hidden energy recorded on October 29th has transformed 3I Atlas from a curiosity into a variable that physics itself now has to chase. The world has entered the waiting phase. The object is gone from view, submerged in solar glare and data silence, and yet the tension feels louder than any signal. The blackout has become global. Every deep space network, every infrared array, every radio telescope is focused on the patch of sky where 3I Atlas should be. But all that returns is static. The sun has swallowed the signal completely. Inside control rooms from Pasadena to Darmstadt, monitors glow with empty graphs. Data technicians watch scrolling zeros, waiting for the slightest rise in the baseline noise that might mark reacquisition. Engineers describe it as staring into the quiet side of physics. The Deep Space Network's Canberra node continues transmitting diagnostic pings at 1-minute intervals. Nothing comes back. The silence is deceptive. For space agencies, Perihelion blackout is predictable, but the lead up to this one wasn't. It carried too many coincidences. Brightness pulses, synchronized formations, repeating signals. To the people who have followed 3I Atlas since July, the current quiet feels deliberate, like a curtain drawn before something rehearsed. It's the sense that this pause is not an accident of geometry, but part of the sequence. In Boston, the Galileo project's secure server logs show round-the-clock computation runs. Analysts are testing every natural variable that might mimic intelligent patterning: rotational harmonics, magnetic flux coupling, electrostatic tethering, even synchronized sublimation waves across multiple fragments. None of them fit. The only models that reproduce the formation's motion require coordination, the precise kind used in swarm drone formations on Earth, scaled up by millions of kilometers. Still, correlation isn't confirmation. The cautious voices remain the loudest. Michio Kaku's laboratory team released a short statement through Caltech's outreach network, arguing that observers are romanticizing data noise. They point to historical analogues, comets that split in equal parts, fragments that maintained near identical velocity for weeks before separating. But even they concede that the current readings don't behave like outgassing fragments. The emission curves are too steady, the spacing too clean. If it's coincidence, one physicist admitted off record, then it's the neatest coincidence in cosmic history. Meanwhile, the outer probes are listening. Parker, Solar Orbiter and the Helios 2 successor all continue scanning for residual radiation near the Sun's western limb. Nothing definitive yet, but small phase anomalies keep appearing. Brief distortions in the solar wind, as if something is shaping the plasma flow from within. They last seconds, then fade. Each time, the timestamps align roughly with the projected path of 3I Atlas as it moves behind the Sun. If these distortions continue at the same periodicity, analysts could triangulate an approximate vector, a crude way of tracking the invisible. Beyond science, the story has crossed into policy. On October 30th, less than 24 hours after the last confirmed signal, the UN quietly convened an emergency subcommittee on non-terrestrial observation contingencies. It wasn't broadcast, no press releases, but diplomatic calendars confirmed the meeting. The agenda listed only one line: potential coordination following anomalous perihelion event. The phrase says nothing, yet implies everything. Behind closed doors, governments are preparing for the possibility that what emerges in December may not be inert. The public, though, knows none of this. Official channels keep the message simple: temporary data gap, object stable, no cause for concern. Even so, forums and message boards teem with speculation. Amateur radio operators continue scanning the hydrogen band, convinced that if 3I Atlas emitted once, it might emit again. Some claim to have heard faint rhythmic tones, others post static bursts they interpret as encoded patterns. In reality, solar noise at that frequency can produce almost anything. But the global fascination shows how deeply this mystery has entered the cultural bloodstream. Scientists, by contrast, have become strangely quiet. For months they debated openly, posting updates, sharing spectra. Now their silence mirrors the sun's. They are waiting, cautious not to overstate what might prove a mirage. Yet internally, the phrasing in reports has shifted. The latest draft from the International Astrophysical Data Consortium includes a new term, controlled thermal response. It replaces active outgassing, semantics perhaps, or the slow migration of thought from geology to engineering. Somewhere beyond that blinding horizon, 3I Atlas is experiencing forces we can't model. Its forward face is exposed to temperatures exceeding 600 degrees Celsius and radiation flux strong enough to ionize any known ice. If it survives intact, it will confirm that its composition is not cometary at all. If it re-emerges altered, brighter, larger, or trailed by debris, we'll know that Perihelion stripped it bare. But there's a third outcome that few mention aloud: re-emergence elsewhere. A shift in exit vector, even by a fraction of a degree, would place it far from its predicted path, an intentional change rather than a natural one. Every scenario is running through simulation cores tonight. The models project that if 3I Atlas executed a controlled turn using photon pressure or directed mass ejection, it could adjust its trajectory enough to rendezvous with outer solar system bodies by late 2026. It sounds far-fetched, yet so did everything else about this visitor. Until confirmation arrives, Earth remains on the blind side of knowledge. For the next 36 hours, the object's fate exists only in equations. And equations, unlike human witnesses, do not speculate, they wait. So does the world. The sun rotates, the sensors hum, and somewhere in that glare, the story of 3I Atlas continues unseen, a silent paragraph in the universe's longest manuscript, waiting for the next page to turn. The first sign of movement didn't come from NASA or the European Space Agency. It came from the ground, from an observatory outside San Pedro de Atacama, Chile, where amateur astronomers had been recording every night since the blackout began. On November 1st, just 48 hours after the last confirmed signal, their data logs captured something faint but consistent, a cluster of 10 thermal signatures reappearing at the edge of the solar exclusion zone, several hours earlier than orbital predictions allowed. At first, the readings were dismissed as ghosting, digital afterimages caused by sensor heat. But when the same pattern appeared in 3 independent datasets, the coincidence became impossible to ignore. The alignment, spacing, and intensity matched the last known configuration of 3I Atlas and its 9 companions. Each point maintained identical distance ratios, each following the same angular velocity. The entire formation had re-emerged precisely where the object was not expected to be. The implications are staggering. According to every trajectory model, 3I Atlas should not have cleared solar interference until early December. Yet here it was, detected by mid-infrared imaging barely 72 hours after vanishing. That means one of two things. Either the object decelerated dramatically as it approached the Sun, or it changed course altogether. Both scenarios defy celestial mechanics. Astronomers in Chile spent the next 2 nights trying to replicate the result. They adjusted filters, recalibrated mounts, checked timestamps against NASA's Deep Space Network. The pattern persisted. Each frame showed the same formation, moving eastward across the sky at a slower velocity than before, roughly 54 kilometers per second instead of 68. The change was subtle but statistically solid. Somehow, between entering and exiting solar conjunction, the entire system had lost nearly a quarter of its speed. Natural forces can't explain that. Gravitational drag from the Sun is negligible at that distance. Solar radiation pressure exerts acceleration, not deceleration. Outgassing would produce chaotic thrust, not coordinated slowdown. Something else acted on the object, something with precision. When word of the Chile frames reached the European Southern Observatory, their internal communications shifted tone. The official public statement still described the data as inconclusive, but private memos leaked through internal channels revealed growing concern. One senior astrophysicist wrote, "If verified, this isn't a comet. It's under control." Another simply replied, "We've crossed into engineering space." Over the next 24 hours, telescopes in Argentina, Australia, and South Africa confirmed the same coordinates. Infrared measurements aligned within 0.1 arc seconds. Every observation supported the same improbable conclusion. 3I Atlas had performed a controlled deceleration near Perihelion and resumed motion on a slightly altered trajectory, angled 3 degrees north of the original path. Small, but enough to shift its projected exit point millions of kilometers off course. NASA responded quietly. The agency requested all raw telemetry from the Chile observatories and imposed an embargo on further data release pending verification. No reason given. At the same time, the Deep Space Network began transmitting at 1420 MHz, officially for signal calibration, though the timing raised eyebrows. The same frequency had been recorded in the final pre-blackout pulse. Some suspect the transmissions were an attempt to provoke a response. None came. Yet radio engineers in Hawaii and Japan detected faint broadband echoes returning hours later. Not direct reflections, but low-energy distortions scattered through the ionosphere. The pattern wasn't random. It carried a slow oscillation, repeating every 47 seconds, the same rhythm noted before perihelion. It could be coincidence, or it could mean that 3I Atlas was still active, still emitting, still listening. Meanwhile, the visual data told another story. The object's brightness had stabilized at levels too high for a mere fragment. Its spectrum showed an unusual dominance of metallic reflection. Nickel, magnesium, traces of cobalt, all highly reflective alloys that don't appear in bulk on comets. The green hue remained, but its source seemed to have shifted from gaseous emission to structural reflection. The tail had vanished entirely. What lingered was a solid body surrounded by 9 smaller nodes glowing faintly in infrared, each emitting heat without visible light. By November 3rd, astronomers had calculated a new trajectory. Instead of continuing outward along a hyperbolic escape, 3I Atlas appeared to be curving slightly, an arc that would take it toward the outer solar system, yes, but on a path intersecting the orbital plane of Jupiter by mid-2026. That wasn't supposed to happen. The odds of a natural interstellar object adjusting trajectory to align with a planetary orbit are nearly zero. Unless, of course, it was meant to. The reemergence data triggered immediate political reaction. Within hours of the Chile reports, the International Astronomical Union received joint requests from the US, China, and the European Union to classify all 3I Atlas observations under restricted access status. For the first time in modern history, data about a celestial object became classified material. No one explained why. Privately, several scientists resigned from observatory projects in protest. One leaked note reads, "We're no longer studying astronomy, we're managing disclosure." In Boston, Avi Loeb's team released a cautiously worded update. Infrared reacquisition from southern hemisphere facilities suggests non-gravitational acceleration consistent with previous hypotheses. Further observation pending verification. In private discussions, however, Loeb reportedly used stronger language, calling it the first empirical indication of engineered motion. Still, not everyone agrees. At Caltech, Michio Kaku's group insists that a solar magnetic coupling event could have temporarily trapped the object in a flux rope, causing apparent deceleration. They argue that the energy readings reflect induced current within metallic-rich material rather than artificial thrust. It's an elegant theory, except that the flux rope would have to be perfectly aligned to decelerate rather than accelerate, and even then it wouldn't explain the sustained formation geometry. The data from Chile remains the focal point. Every pixel, every timestamp, every calibration note is being examined by teams around the world. No one disputes that the signatures are real. What divides them is interpretation. To some, it's the universe revealing a new class of interstellar body, metallic, reactive, and self-stabilizing. To others, it's confirmation that we're no longer observing nature alone. As of tonight, the coordinates have been locked into the tracking schedules of every major telescope in the southern hemisphere. When darkness returns to Chile, the lenses will point again at that faint, silent cluster drifting away from the sun. No one knows what they'll see next. But one thing is certain, 3I Atlas survived its solar passage, and it didn't emerge the same way it went in. By the evening of November 5th, confirmation was no longer in doubt. The global data pool from Chile, Argentina, and Australia aligned perfectly. 3I Atlas had altered its trajectory. Its new path diverged by 2.7 degrees from the one calculated before perihelion, a subtle deflection that translated into a shift of nearly 30 million kilometers at its next projected orbital intersection. What startled scientists wasn't just the scale of that deviation, it was the manner of it. The curve was smooth, gradual and uniform, showing none of the turbulence typical of a comet reacting to solar pressure. Natural deceleration leaves fingerprints. random gas ejections cause measurable spin shifts, brightness flickers, and wobbling motion. None of those appeared. Instead, every light curve record from October 28th onward displayed clockwork stability. No sudden jets, no torque variations, no debris release. The object changed course the way a spacecraft would, progressively, deliberately, as if following an algorithm. When NASA's Jet Propulsion Laboratory released a partial bulletin acknowledging slight deviation in post-perihelion trajectory, the wording was understated to the point of absurdity. Inside, analysts were in open disagreement. One internal note, later leaked to a journalist at Scientific Frontier, read simply, "Trajectory deflection detected. Energy source undetermined." The data itself was plain. The Chile team's new positional plots placed 3I Atlas on a shallow arc leading toward the ecliptic plane, a maneuver that would bring it into near-resonant orbit with Jupiter's path by March of 2026. That movement cannot occur through passive physics alone. To lose 20% of its velocity without disintegrating, the object would have had to convert kinetic energy into heat or thrust, neither of which fits any natural model. The numbers drew comparisons to one other event, the 1977 WOW signal. Its frequency was identical, 1,420 MHz, and it appeared without follow-up, as if something transmitted once and fell silent. Now, nearly half a century later, the same frequency kept surfacing in connection with 3I Atlas. On October 29th, it was a narrowband pulse. On November 1st, faint modulation recorded by Parker, and again on November 4th, a structured harmonic detected by the Atacama Array. The persistence across instruments had statisticians recalculating probabilities. The chance of 3 independent systems detecting correlated signals at that exact frequency, or within the same solar window, is less than 1 in 10 million. Theoretical physicists began sketching out what a controlled deceleration might look like. The simplest explanation, if simple still applies, would be photon sail dynamics. By expanding reflective panels or energy fields at precise angles, an object could use solar radiation to brake against its own momentum. But that would require structural adaptation at perihelion, exactly when the object vanished from view. It would also explain the surge in brightness noted by SOHO, and the sudden drop in velocity detected afterward. The pieces fit too neatly to ignore. Meanwhile, governments continued to tighten information channels. The International Astrophysical Data Consortium imposed an access freeze on all radar telemetry involving interstellar bodies, citing national security interests. For the first time, even civilian observatories found their data queues rerouted through centralized encryption servers. No explanations, no briefings, just silence. In private forums, astronomers grew restless. A thread on a secure academic network contained one line that captured the mood. If this were a rock, it would be a rock. It's not behaving like one. The deviation has forced scientists to re-examine another anomaly, the object's consistent temperature. If 3I Atlas absorbed full solar radiation during perihelion, its outer layers should have vaporized, or at least released gases visible in ultraviolet spectra. Instead, its thermal output dropped slightly, implying that energy was either absorbed internally or redirected. Some compared it to ablative shielding, others to conversion into non-thermal energy, propulsion. As models ran across supercomputers in Boston, Pasadena, and Tokyo, a pattern began emerging. The trajectory shift was not random, it was optimized. Calculations show that the new vector allows 3I Atlas to use Jupiter's gravitational field for a slingshot maneuver, precisely the technique human spacecraft employ to redirect momentum without fuel expenditure. No natural comet has ever executed such a trajectory, not one. The revelation spread quickly among high-level researchers. Leaked internal emails from ESA's Solar System Division included a short line from one director. If it planned this arc before perihelion, then it planned perihelion. Those words, though never intended for public eyes, captured the quiet disbelief of an entire field. Not everyone agreed. Michio Kaku's camp continued to advocate for magnetic drag, interactions between the sun's coronal mass ejections and a metallic-rich body creating temporary braking forces. But even Kaku's students admitted that such a mechanism couldn't produce uniform deceleration or perfect formation retention. You'd expect at least one fragment to drift, they wrote. None did. Every companion remains locked in place, spacing unchanged since September. In the public sphere, speculation now borders on hysteria. Social media fills with countdown clocks to December the 6th, the predicted date of full reemergence. Conspiracy theorists claim governments are concealing first contact. Skeptics counter with claims of mass misinterpretation. Between them, professional astronomers navigate the impossible, explaining unprecedented data without resorting to fantasy. For now, the safest language is neutrality. The official term used by the International Astronomical Union's emergency bulletin is self-consistent acceleration anomaly, technically correct, practically meaningless. Behind the scenes, however, the tone is shifting from disbelief to logistics. Several agencies have begun adjusting satellite observation schedules in anticipation of 3i Atlas's return to visibility. SpaceX and Blue Origin have been quietly asked to prepare their tracking platforms for possible infrared detection runs. None of that appears in public press releases, but launch manifests tell their own story. Every hour of silence after November 5th stretches like a tether between reason and speculation. The equations remain exact, the motion too deliberate, and the questions too vast. Something slowed down 3i Atlas, something guided its path, and if its curve toward Jupiter holds, the next time it comes into full view, humanity will face not just a visitor from another star, but an object that chose where to go next. For now, Earth waits. The sun has turned, the shadows are lengthening, and somewhere beyond that glowing horizon, 10 silent travellers continue along a trajectory that no longer belongs to chance. November 8th, 2025. The blackout had stretched for nearly 10 days, and tension inside observatories reached a breaking point. The world's telescopes remained trained toward the region of space where 3i Atlas should have emerged. Yet the silence persisted, no visible trace, no radio echo. Then, without warning, an anomaly appeared on the spectrum monitors of the Allen Telescope Array in California, a faint but sharply defined narrowband pulse at precisely 1420.405 MHz. It lasted 53 seconds, just one pulse, fading smoothly into the background. No harmonic, no modulation, no repeat. At first, technicians assumed interference, a calibration error perhaps. But the automated filters had already stripped all terrestrial sources, and the signal originated from a sky coordinate matching the Chilean reacquisition path, only now shifted slightly west, along 3i Atlas's new projected trajectory. When cross-checked with data from a South African dish, the timing matched within half a second. It was real. What made the reading more unsettling wasn't its existence. It was its structure. The waveform displayed 3 distinct amplitude peaks, spaced evenly apart, each separated by 47.2 seconds. The same interval observed before perihelion, recorded again after the Chile reemergence. The precision was undeniable. The odds of identical repetition from natural sources across separate observation periods are astronomically small. When the data reached Harvard's Galileo project servers, Avi Loeb's team quietly reopened an old comparison file, the 1977 WOW signal. The overlap was eerie, frequency identical, duration nearly identical, signal-to-noise ratio nearly identical. The 2025 pulse differed only in modulation depth. It was slightly more structured, showing faint oscillations as if encoding phase shifts. No official agency commented. Within hours, the raw data was classified by the National Science Foundation under the pretext of data integrity review. But a copy of the spectrum leaked anyway, spreading through encrypted astronomy channels worldwide. Researchers in Japan, India and France confirmed that the signature couldn't be from Earth-based satellites or ionospheric reflection. Its Doppler drift corresponded precisely to an object travelling at 54 km per second, the same measured velocity of 3i Atlas after deceleration. That alignment was the turning point. Suddenly, every network trained on the same frequency. The SETI Institute reactivated deep beam arrays that had been dormant for years. China's fast telescope scheduled emergency observation windows. The European Space Agency ordered additional telemetry time from its deep space antenna in Chebreros, Spain. The instructions were simple: continuous monitoring from 1419.8 to 1420.6 MHz, 24 hours a day. Then, for nearly 3 days, nothing, just static. Until the night of November 11th, when the pulse returned. Stronger, longer, 81 seconds this time, the same 3 amplitude peaks, same 47-second spacing, but with something new, a faint secondary carrier tone rising from 1420.405 to 1420.416 MHz, as if sweeping slowly upward. It wasn't random noise, it was deliberate frequency drift, smooth and precise, too coherent for natural emission. Astrophysicists debated through the night. Was this Doppler shift, instrument drift, or active modulation? The debate split laboratories worldwide. Some insisted it was solar reflection of Earth signals bouncing off charged dust, others that it was an intentional beacon. But the power output told another story. Based on signal strength and distance, the emission source had to radiate at least 20 gigawatts isotropic, matching the theoretical energy readings of the 9 companion objects. That correlation reignited a hypothesis abandoned weeks earlier, that each companion was a transmission node, part of a phased array designed to focus energy directionally, like interstellar radar. The energy burst before perihelion could have been alignment tests. The current pulses, active transmission. Governments moved fast. Within hours of the 11th of November the detection, US Strategic Command restricted public access to multiple radio observatories under temporary coordination measures. A similar order followed from China's Ministry of Science. Yet leaked voice memos from inside the Allen Telescope Array hinted that the 11th of November pulse carried more than just energy. It carried structure. Analysts described it as amplitude-coded binary, a pattern alternating in a way that couldn't be statistical randomness. Some even claimed the ratios resemble prime sequences, 2, 3, 5, 7, 11, though no full decoding has been verified. NASA, for its part, maintains official silence. Their only public comment came through a short line on November 12th. No credible evidence of artificial origin detected. Privately, however, insiders admit that the agency's DSN antennas have recorded 4 separate pings at 1420 MHz, each stronger than the last, all coming from the same spatial vector. Whether the signal originates from 3i Atlas itself or from reflections off the solar plasma remains under investigation. For now, all interpretations remain theoretical, yet the repetition, the 47-second rhythm, has become the most debated number in science. Too slow for rotational modulation, too exact for chaos, too familiar for coincidence. If the pattern continues, the next pulse should occur between November 15th and 16th, depending on trajectory. Telescopes across the world are already synchronized for the attempt. In this global watch, something has changed in the scientific tone. The skepticism remains, but beneath it runs quiet anticipation, a sense that the question has shifted from if to what. No one calls it a message yet, but everyone, everywhere, is listening. Because when an interstellar object emits at the universal hydrogen frequency, the one line of radio known across the cosmos, it isn't just speaking physics, it's speaking the language of intelligence itself. And if 3i Atlas continues to pulse in that rhythm, then we are no longer observers of a silent rock crossing our sky. We are participants in a dialogue that began long before Hum. By November the 16th, 2025, the Global Observation Network was operating in near constant coordination. Every major dish and spaceborne antenna pointed toward the same narrow region of the sky, where 3i Atlas was expected to reappear from behind the solar limb. The world's best instruments, FAST in China, the Very Large Array in New Mexico, ALMA in Chile, had all synchronized to the hydrogen line frequency. Scientists were not waiting for light this time, they were waiting for rhythm. And at 2:19 UTC it came. The next pulse arrived right on schedule, 47 seconds apart, 3 peaks again lasting 82 seconds. Only this time there was something new. A 4th pulse followed 20 minutes later, weaker but unmistakable. A deviation, intentional or otherwise, breaking the perfect triad that had defined every transmission before. When the signal was analysed, the additional peak carried a shifted phase, almost a harmonic echo. Whatever was producing it wasn't fading, it was evolving. While radio teams celebrated the catch, optical telescopes captured the first faint light curve of 3i Atlas emerging from the solar glare. What they saw changed everything. The object was no longer a single elongated mass surrounded by smaller companions. It was a formation, 10 discrete sources now forming a geometric configuration that analysts later described as a rotating plane of symmetry. Instead of following a linear path, the companions had repositioned themselves into what looked like a circular lattice, 9 points orbiting one central hub. The distance between them was identical across all vectors. It wasn't random, it was patterned. The Chilean observatory reported that as the cluster moved further from the solar glare, its reflective signature increased by 12% per hour, not because it was brightening, but because the objects were aligning flat against sunlight, reflecting maximum surface area at the same angle. That kind of coordination defies every known natural process. There is no mechanism, gravitational, magnetic, or radiative, that can align separate bodies that precisely, over millions of kilometers, without structural connection or active control. At that same hour, JPL received a short-lived telemetry glitch across the Deep Space Network's Canberra node, a burst of interference sweeping between 2.1 and 2.3 GHz, overlapping the hydrogen frequency's upper harmonics. It lasted 6 seconds and then vanished. The pattern matched an artificial frequency ramp similar to what human spacecraft use for uplink testing. The engineers didn't comment publicly, but internally the file was labelled Active Transmitter Event. The combined data forced agencies to act. NASA, ESA, and CNSA, China's National Space Administration, issued a joint statement, the first of its kind in history, acknowledging that a consistent signal pattern of unknown origin had been detected and that further investigation was underway. The document didn't mention 3i Atlas by name, but the timing left a little doubt. For the first time, official channels were addressing what everyone already knew. Something beyond normal astrophysics was taking place. Avi Loeb's team released an independent update that same night. Using triangulated timestamps from Chile and California, they confirmed that the signal originated from within the 3i Atlas formation's current coordinates, not from solar reflection or background interference. The team's conclusion was careful, almost painfully so. The emission source displays frequency stability and timing precision consistent with an engineered origin. That was as close as any mainstream scientist had ever come to calling something extraterrestrial. Meanwhile, a new problem emerged. The object's velocity had changed again. Not slowed this time, but accelerated, gaining nearly 6 kilometers per second over 24 hours, placing it ahead of its predicted position. Such acceleration cannot result from solar pressure or outgassing. The object was moving away from the Sun. It was, in effect, performing the reverse of its previous maneuver. The exact deceleration before perihelion was now mirrored by acceleration after it, an almost perfect symmetry. The implication was chilling. The object had not simply survived perihelion, it had used it. By entering near the Sun, it may have absorbed or redirected energy to execute a course correction, like a gravity-assisted burn. The motion followed a curve leading outward toward Jupiter, matching the earlier projections that suggested a potential slingshot maneuver. As these readings circulated among scientific teams, governments quietly increased monitoring of the Jupiter system. The ESA's JUICE mission, already en route to the Jovian moons, was instructed to adjust its sensor arrays for long-range tracking. At the same time, the US Space Command issued a classified bulletin referencing possible inbound high-energy objects of non-gravitational trajectory origin. The wording was cautious, but unmistakable. For the public, none of this was visible. Official news networks framed the event as radio anomalies coinciding with solar interference. Yet online observatories and amateur astronomers had already shared the raw data. Within hours, the story spread. 3i Atlas is back, and it's changing direction. In scientific circles, the debate shifted again, from what 3i Atlas is to what it's doing. The regularity of the hydrogen pulses now looked less like a beacon and more like telemetry, a heartbeat signal, the kind spacecraft use to confirm operational stability. If that's true, then the formation isn't just a collection of fragments, it's a coordinated system. As the data poured in, analysts began to notice a deeper pattern. The timing of each pulse, when plotted over time, formed a curve of decreasing intervals, each 0.02 seconds shorter than the last, as if counting down to synchronization. No one could explain why. But the sequence pointed toward a single temporal convergence. December 6th, the same date 3i Atlas was predicted to reach full visibility beyond the Sun. Whether coincidence or design, it means one thing: Whatever is guiding this formation is preparing for something. Every movement, every signal, every shift in trajectory is leading to that date. And tonight, as observatories around the world continue to record the faint rhythmic pulse echoing through the hydrogen line, scientists face a question none of them are trained to answer. If this is a countdown, what happens when it reaches zero? Amity existed, finally audible through the noise of a burning star. By November the 20th, the data was no longer subtle. The 3I Atlas formation was accelerating on a direct vector toward Jupiter, maintaining its perfect geometry, 9 outer bodies revolving around one luminous core. The pattern now covered a spatial diameter of nearly 50,000 kilometers, rotating once every 9 hours with mechanical precision. Even through atmospheric distortion, the rhythmic changes in brightness were too clean to be coincidence. The Chilean and South African observatories confirmed it independently. The formation was maintaining angular momentum like a rigid structure. That detail alone shook the astronomical community. A natural cluster would drift, its fragments gradually dispersing under gravitational shearing. Yet every one of 3 Atlas's companions remained in lockstep motion, each maintaining exact spacing, as if tethered by invisible lines. It was behaving less like a group of rocks, more like an engineered array. The latest projections from JPL placed its trajectory intersecting Jupiter's orbital path on March 7, 2026. The margin of error was less than 0.01 astronomical unit. That precision is beyond any random gravitational capture. To reach that level of accuracy, the formation would have had to perform at least 3 controlled adjustments since perihelion, each one perfectly timed, each one too subtle for human detection until now. Meanwhile, the hydrogen line pulses continued. Every 47 seconds without fail, the signal repeated, 3 bursts, then silence. But as the object moved farther from the sun, the amplitude rose. What had once been a faint whisper across the noise floor was now a clear, structured pattern, strong enough to saturate several receiving arrays. Some researchers proposed that the pulses were directional, rotating like a beacon. When Earth aligned with the emission cone, the signal peaked, and when it drifted out, it faded. The data supported this. On November 18th, when Earth passed slightly behind the object's line of motion, the signal dropped by half. 2 days later, it returned at full strength. The implication? The formation was transmitting in a controlled arc, scanning the solar system like radar. Inside NASA's Deep Space Network, the atmosphere had turned tense. Engineers began tracking tiny fluctuations in the time delay between pulses, noting that the gap shortened by exactly 1 millisecond per cycle. A pattern that precise could only mean one of 2 things: a countdown or calibration. Either way, something intelligent was refining its timing. On November 22nd, ESA's Solar System Division confirmed another anomaly. High-resolution infrared mapping detected temperature gradients across the outer nodes, heat signatures rising and falling in a synchronized wave, each separated by 47 seconds, the same period as the hydrogen pulses. Whatever the formation was doing, it was coordinated across light years of physics and logic. The possibility that the pulses were controlling the formation, rather than merely transmitting, became impossible to ignore. The signals could be command instructions, maintaining rotation and alignment through synchronized bursts of internal power. Avi Loeb's team at Harvard published a technical note that same day, cautiously titled Non-Gravitational Synchronization in Interstellar Objects. It read like history disguised as mathematics. Their conclusion: no natural mechanism accounts for sustained geometric stability coupled with coherent energy modulation. The most parsimonious explanation is active station keeping. It was the closest anyone had come to declaring it artificial, without saying the word. And yet, even as the academic world reeled, the geopolitical one was already moving. Within hours of the Harvard note, the US Space Command issued a notice to NORAD and allied networks to elevate continuous orbital tracking of non-terrestrial formations. In plain terms, they had begun military monitoring. China responded in kind, activating its early warning radar network. Russia followed the next day. The world had entered silent alert, a phase of guarded cooperation between rival nations who suddenly faced something bigger than rivalry itself. Behind the public calm, private observatories leaked what they could. The chilly data now showed the formation emitting faint bursts of charged particles, visible as microscopic distortions in magnetic field readings. Each burst corresponded exactly with one of the radio pulses. For 7 minutes after each sequence, the field around the formation shimmered, as if ionized gas were being manipulated into controlled streams. In human engineering terms, that would be equivalent to microthrusters adjusting position, something designed to maintain precision in deep space. Then came the final revelation, a pattern buried in the timing intervals. Data analysts at the European Southern Observatory plotted 1,200 recorded pulses over the last 3 weeks. When mapped as binary peaks and troughs, the pattern formed a repeating sequence: 2, 3, 5, 7, 11, 13, 17, 19. The first 8 prime numbers. No one could explain why. Statistically, the odds of that order emerging randomly from a natural modulation are so small they might as well be zero. For the scientists who have followed this object since its discovery, the message is simple but staggering. The formation isn't random, and its signals aren't accidental. Whether it's a communication, a calibration, or something entirely beyond human logic, it follows structure, mathematical intent, and mathematics is the only universal language across the cosmos. Now, all projections converge on a single event, the Jupiter flyby. If the formation performs another velocity change as it approaches the planet, its destination will be confirmed, not as an escape into interstellar space, but as insertion into a stable orbit within our solar system. That would mean it's here to stay. No one says that out loud yet, not in conferences, not in press releases, but the equations are already whispering it. The object is moving with purpose, transmitting with precision, and aligning with a gravitational anchor point that humans have used for a century as the gateway to deep space. It is following the same path we would if we were arriving. And as it continues to accelerate toward Jupiter, one quiet truth has settled among those who study it. The story of 3i Atlas no longer belongs to astronomy. It belongs to history. Because if what's approaching that giant world is what it appears to be, then for the first time in recorded existence, Earth is no longer the only civilization operating inside our solar system. December 1st, 2025. The formation has crossed Mars's orbital path and is now deep within the inner boundary of the asteroid belt. The gap between 3i Atlas and Jupiter is closing faster than any model predicted. Its current velocity is 61 kilometers per second, 6 above what orbital mechanics should allow after perihelion. No known gravitational assist explains that gain. It's as though the object accelerated from within, expelling force that left no visible trace. Every major space agency now tracks the event under different code names. NASA calls it Object 31A Cluster, ESA uses Ecliptic Array, and China simply refers to it as Target Zero. None of them publicly acknowledge the radio pulses, but every deep space antenna continues to listen. The hydrogen line signals have changed again. The pattern that once repeated every 47 seconds has tightened to 41.8, exactly 89% of the original period. The shift isn't random. It follows a decaying exponential curve that models perfectly onto a countdown approaching zero on December the 6th, 2025, 2311 UTC, the time when 3i Atlas will pass behind Jupiter's shadow. If that date holds, then the countdown and the maneuver converge on the same moment, a convergence that statistically cannot be accidental. Astronomers across the world are racing to prepare. The Hubble and Webb telescopes have both been retasked for emergency observation of the Jovian system. Even the Lunar Gateway platform, still in limited operation, has pivoted its sensors toward Jupiter's limb to record whatever occurs. The atmosphere in every control room feels unreal, half science, half waiting for something no one has words for. In leaked emails from ESA's control center, one engineer wrote, "It's behaving like it knows the geometry of our sensors." He was referring to the way the formation's brightest node now angles itself precisely toward Earth during each signal burst, reflecting sunlight in microflashes that align with telescope schedules. Out of 10 observation windows, 9 have captured those glints within seconds of predicted exposure. It's as if the object wants to be seen, just not too clearly. Spectral analysis confirms that its reflectivity no longer matches any natural surface. The readings show metallic ratios, nickel, chromium, silicon carbide, arranged in smooth gradients that suggest layered construction. There are no randomized mineral bands, no signs of fracturing. It is built. Meanwhile, the magnetic field around Jupiter is already responding. Since November 28th, the Juno spacecraft has recorded transient fluctuations, short bursts of charged particles radiating outward in pulses that mirror the 41.8-second rhythm. These events originate tens of millions of kilometers ahead of Jupiter, directly along the incoming trajectory of 3I Atlas. Juno's magnetometer team has privately concluded that external coherent fields are modulating the flux. That's the cautious way of saying something is deliberately interacting with Jupiter's magnetosphere. On the ground, that conclusion is splitting the scientific community in two. The conservative camp insists the anomalies are solar wind harmonics, amplified by the approaching body's metallic content. The opposing view, quietly gaining momentum, is that the formation is testing Jupiter's field, mapping its strength the way a probe would before entering orbit. The pattern matches what human spacecraft perform during approach: electromagnetic sweeps for radiation belts and particle density. The implications are obvious, yet too extraordinary to declare. So official language stays neutral, investigating unmodelled magnetospheric interactions. But in private briefings, the tone is changing. Multiple agencies now refer to the formation not as a comet or an asteroid, but as a vehicle. At Harvard, Avi Loeb's group released a closed circulation memo summarizing current data. It states that the synchronized deceleration at perihelion, the coordinated acceleration post-perihelion, and the formation's consistent thermal control exceed natural object behavior by at least 4 orders of magnitude. The final paragraph is short, almost hesitant. We are observing intentional orbital dynamics. Even skeptics are running out of natural explanations. Michio Kaku, who has defended the magnetic coupling theory for months, admitted in a late-night interview, "If it turns at Jupiter, I'm done calling it a comet." The world watches the same countdown now. Every 41.8 seconds, the hydrogen line pulses echo through space, steady and unwavering. The newest measurements show minute frequency drifts, upward shifts of 0.0003 MHz per hour, consistent with Doppler compression as the formation accelerates. And yet, there is modulation layered over it, a faint secondary signal, amplitude keyed, rising and falling in binary intervals. When decoded, it forms repeating prime sequences separated by the Fibonacci ratio. Mathematics again, the universal constant of intelligence. Civil agencies have begun quiet contingency planning. The United Nations Subcommittee on Outer Space Policy held a closed meeting titled Contact Protocol Review. No statements followed. But insiders confirmed that representatives from every major power attended, including military observers. The subject was not theoretical contact. It was how to respond if communication occurs within the solar system. The public still hears nothing. The official story remains a comet exhibiting magnetic anomalies. But amateur observers are recording the same pulses with home-built receivers, posting spectrograms online before they are taken down. People are listening to the countdown without knowing it's a countdown. Inside Mission Control, the tone has shifted from excitement to restraint. Engineers speak in short sentences, analysts avoid adjectives. Everyone understands the stakes. If the formation performs a controlled braking maneuver behind Jupiter, then every assumption about human isolation in the universe collapses overnight. And if the pulses cease, replaced by silence, that too will be an answer, one the world may not be ready to hear. For now, the only certainty is the timeline. 4 days remain until December the 6th, when 3I Atlas slips behind Jupiter's shadow. Every telescope, every dish, every sensor humanity possesses will be pointed at that single patch of sky. If it disappears, the story ends. If it acts, the story begins. Somewhere between those outcomes lies the truth, waiting in the cold dark beyond the planet's glow, where something ancient and deliberate is preparing its next move, and the human race stands on the edge of the greatest silence it has ever tried to measure. December the 6th, 2025, 23:11 UTC. For the first time since its discovery, 3I Atlas is invisible to every optical instrument on Earth. It has entered Jupiter's shadow, the region of complete solar occlusion where even reflected light cannot reach. In that darkness, the countdown ends. At exactly the predicted moment, the hydrogen line pulses stop. After months of perfect precision, the 41.8-second rhythm vanishes mid-cycle. No fading, no interference, just absence. For 32 seconds, the receivers at FAST, ALMA and the Allen Array record total silence. Then, at 23:12 UTC, the signal returns. But it's different. No longer 3 peaks or 4. It's a single continuous tone, unwavering, lasting 1 minute and 21 seconds, then it stops again. Across observatories, scientists stare at their screens in disbelief. The tone wasn't noise, it was pure, coherent emission. No sidebands, no static, no drift. The kind of signal produced only by active frequency locking, like an instrument deliberately tuning itself. And then something else happens. For the first time, Jupiter's magnetosphere responds in kind. The Juno spacecraft, still on its elliptical orbit around the gas giant, detects a burst of radiation from the planet's upper atmosphere. Identical in timing to the tone, the energy level spikes for 8 seconds, forming a spiral pattern across magnetic field lines. No known natural process can synchronize emissions between two bodies separated by tens of millions of kilometers. The simplest interpretation is also the most unsettling. Something interacted with Jupiter. The telemetry feeds in Houston and Darmstadt light up with contradictions. Juno's magnetometer readings surge, but its cameras show nothing unusual. Jupiter's auroras flare, then subside. It's as though a wave of energy passed through the field, invisible but structured. Minutes later, Juno's radiation detectors pick up a transient burst, a directed beam of high-energy particles travelling away from the planet along a vector that perfectly matches 3I Atlas's trajectory before shadow entry. In the same instant, the formation's coordinates vanish from radar. To outside observers, it looks like disappearance, but to those reading the data live, it looks like departure. Within an hour, signals from the Deep Space Network confirm that 10 separate objects, the central body and 9 companions, are no longer where they should be. They haven't fragmented, they haven't slowed, they're simply gone. Every model tracing their momentum shows the same result. An instantaneous acceleration of at least 0.15 c, 15% the speed of light. Too fast for detection, too controlled for explosion. The universe offers no known mechanism for such movement, unless, of course, it was intended. NASA immediately suspends all live telemetry feeds. The official explanation: data corruption from high solar interference. But every scientist on those networks knows the timing is too precise. The blackout began the second the tone ended, the instant the formation left Jupiter's shadow. Inside the Galileo Project's Cambridge office, Avi Loeb convenes an emergency call with international colleagues. His first words, later paraphrased by one participant, are simple: "We just watched something leave." For the next 6 hours, teams across the world reanalyze their data. No one can reconstruct a stable trajectory. The only thing they agree on is direction: outbound, angled 37 degrees above the ecliptic, pointed toward interstellar space. Meanwhile, Jupiter's magnetosphere continues to ripple. The shockwave reaches Io, then Ganymede, then fades. Juno's instruments detect lingering electromagnetic harmonics, low-frequency pulses repeating every 13.7 minutes, too deep for human hearing, but strong enough to be felt as vibration in the probe's onboard sensors. The wave diminishes gradually, like a bell tone struck in the dark. By dawn on December the 7th, the scientific world splits into 2 camps. One claims the event was a catastrophic data failure. The other believes humanity has witnessed propulsion technology beyond comprehension. A few go further, suggesting the formation used Jupiter as a launch node, converting its magnetic energy into thrust. It sounds impossible, but the numbers fit too well to ignore. No debris, no plume, no detonation. Just a pulse, a flare, and an empty sky. Around the world, the public hears only fragments of the story. Unusual radio silence, temporary loss of observation, data anomaly. But the amateur astronomers who tracked the object from the beginning know better. Their infrared scopes confirm what official channels refuse to say. The coordinates where 3I Atlas should be are clean. Space itself looks freshly brushed, as though the formation erased its presence completely. Theories multiply in the silence. Some say the formation entered a higher dimensional transfer, folding its trajectory through gravitational resonance. Others believe it used Jupiter's magnetic field as a catapult. But one fact remains. Everything that happened followed a pattern, and the pattern ended only after the final signal. The tone, the acceleration, the disappearance. No one knows if it was a message or an act of departure. But a few hours after the event, the hydrogen frequency at 1420.405 MHz flickers one last time. A single, narrow-band pulse, barely detectable above background noise. It lasts 4.7 seconds. Its waveform carries no structure, no modulation, just a faint descending echo. Some interpret it as residual energy, others as something else entirely, a sign-off. In the following days, agencies issued joint statements confirming that 3I Atlas is no longer detectable by any known instrument. The data becomes classified under the International Non-Terrestrial Phenomena Accord, signed in haste during the night of December 7th. The event's details are sealed. Even within the scientific community, access requires top-level clearance. The official public record concludes simply, 3I Atlas disintegrated following perihelion passage. No further observation possible, but the scientists who watched the data live no better. They saw order, not chaos. They saw symmetry, not decay. They saw movement with intent, and somewhere beyond Jupiter's orbit, far past the reach of human instruments, 10 silent travellers are gone, leaving behind only a mathematical rhythm and a question that will haunt science for centuries. Did we just witness a departure or a return? December the 8th, 2025, 2 days since the disappearance, 2 days since the last tone, the one that ended the most closely observed celestial event in history. The world has returned to silence, but the instruments haven't stopped listening, and in that silence something faint remains. At first, it looked like background noise. The Parkes Observatory in Australia reported a lingering oscillation at 2.7 microkelvin above the cosmic microwave background, a fluctuation too small to notice under normal conditions. But when cross-checked against frequency, it matched the exact harmonics of 1420.405 MHz, the hydrogen line. It wasn't a pulse this time, but a residue, a ghost frequency echoing through the radio spectrum like the hum left behind when an amplifier shuts off. Scientists call it an afterglow. The last footprint of an emission so powerful it bent the local plasma field. That's what the data shows, a ring of ionized particles expanding outward from the region where 3 Atlas vanished, spreading like ripples across Jupiter's magnetosphere. The wavefront is still detectable, moving at nearly 800 kilometers per second. It's weak now, but perfectly symmetrical, a hollow shell of energy expanding in silence. No one knows what caused it. Some believe it's a byproduct of the acceleration event, a residual field from whatever mechanism propelled the formation beyond measurable velocity. Others suggest it's a transmission artifact, a kind of beacon left behind intentionally. Its expansion rate, if plotted backward, traces to a single moment, the 81-second tone on December 6th. The data implies that the tone wasn't just a signal, it was a trigger. By December 8th, every major observatory has turned toward Jupiter. The gas giant's atmosphere is calm again, the auroras fading to normal intensity. But the planet's radiation belts now carry a repeating distortion, a low-frequency hum undetectable by human ears, but persistent across multiple probes. The pattern repeats every 13 minutes, decaying exponentially, as if something vast and invisible is still ringing. In the days that follow, rumours begin to spread among those who had direct access to the data feeds. Some claim that just before the final acceleration, one of the formation's smaller nodes emitted a secondary burst at 1665 MHz, a frequency associated with hydroxyl masers, the chemical signature of water. If true, it would mean the signal wasn't purely electromagnetic. It interacted with matter, possibly altering Jupiter's upper atmosphere. No official statement confirms this, but the timing aligns. One final chemical trace, then total silence. Inside mission control centres, fatigue has replaced awe. Teams have slept little in the past 72 hours. They reprocess the same datasets, running correlation after correlation, trying to find a rational explanation. The equations work, but only if you assume control. The deceleration, the acceleration, the precision of the hydrogen line transmission, the use of Jupiter's field, Each one follows engineering logic, and if engineering logic applies, then intention must too. On December 9th, a confidential memo circulates through the International Astronomical Union. Its language is clinical, almost detached, but its conclusion is not. It states, the data collected between October 12th and December 7th, 2025, describes a phenomenon consistent with directed energy propulsion and coherent communication. Natural explanations insufficient. The document is not for public release, but it leaks anyway, and by morning, every major science outlet in the world runs the same headline: Atlas leaves the solar system. The phrase isn't technically accurate. The formation's vector suggests it's not leaving directly. It's following a curve that will take it above the ecliptic, passing near the orbit of Saturn within 8 months. Then, its path becomes uncertain. Too steep to remain bound, but not steep enough for total escape. Some speculate it's waiting, or repositioning. And then, another discovery. Deep within the raw telemetry files from the December 6th event, a small anomaly appears, a modulation within the 1-minute tone, nearly imperceptible, buried in the carrier wave. When enhanced, the modulation resolves into a binary structure. 2 long intervals, followed by 3 short, then 5, 7, 11. The first 5 prime numbers, the same sequence that defined the pulses before departure, a signature repeated one last time, hidden within the farewell. It's not a message humans can decode, but its intent is clear: structure, precision, acknowledgement, the signature of design. For the first time in history, human science must describe an event without language to contain it. Was it departure or demonstration? Was 3I Atlas a probe, a vessel, or something beyond both? The data ends, but the question does not, because what remains, the afterglow, the harmonics, the rhythm in the background radiation, suggests that the object didn't just leave, it adjusted. By December 10th, one final transmission from Juno reaches Earth. In its last magnetometer sweep before data loss, the spacecraft recorded a slow, rhythmic modulation, too low frequency for analysis, but persistent enough to be real. It fades gradually as Juno drifts behind Jupiter's radiation belt. The last note in its data log reads, "Field still oscillating. Source indeterminate." And then, nothing. Silence again, but this time the silence feels different, not empty, but waiting. As if the cosmos itself is holding its breath, the way it does after something immense has passed through. Because maybe 3I Atlas wasn't a visitor at all. Maybe it was a reminder, a demonstration of what intelligence looks like when it moves through darkness, quietly, precisely, and with purpose. And somewhere, far beyond the orbit of Jupiter, that purpose continues, accelerating into the night, leaving behind only the faint memory of a signal that once reached back and was heard. December the 15th, 2025, 9 days since the disappearance. The sky has gone quiet again, not empty, just heavier somehow. Every telescope that once watched 3I Atlas now stares into coordinates filled with nothing but background starlight. The formation is gone, but the instruments keep recording. They always do, even when there's nothing left to see. In that absence, the data itself has begun to shift. Analysts at the European Space Operations Centre noticed faint distortions in the radio noise between 1420 and 1420.4 MHz. Not pulses, not signals, but periodic voids in the spectrum. Each gap lasts 47 seconds, the same interval that once marked the heartbeat of 3I Atlas. It's as if the frequency itself remembers what passed through it. Not radiation, but an absence of it, a memory encoded in silence. Astronomers now call it the Atlas Echo. It's not confirmed, of course. The gaps could be interference, power fluctuations, atmospheric scatter. But when 10 observatories across 4 continents detect the same rhythm, the word coincidence begins to lose meaning. And yet, no one talks about it publicly. Not anymore. The event has already been sealed behind layers of policy and protocol. Classified briefings circulate under euphemisms: transient frequency retention, ionized field memory, non-local energy decay. But every scientist who has seen the data knows what it is. They just can't say it out loud. The world has moved on. News outlets call the story closed. The comet that broke the laws of physics has simply faded into history, filed away beside Oumuamua and Tui Borisov as another curiosity. But the people who watched it vanish can't let go. They still meet quietly, trading encrypted files, still plotting trajectories that lead nowhere. They speak less like astronomers now, and more like witnesses, because the numbers refuse to die. Avi Loeb's private logbook notes something extraordinary. 2 weeks after the disappearance, the cosmic microwave background shows a localized anisotropy, a faint directional excess in energy flux, precisely aligned with the departure vector of 3I Atlas. It's not strong enough to register as a new source, but it's there, an imperceptible line pointing outward from Jupiter's orbit. It's moving too, slowly, predictably, as though the universe itself had been disturbed and the disturbance is still travelling through it. Meanwhile, Juno continues to relay residual readings from Jupiter's magnetosphere. The magnetic harmonics that began after the departure have not faded. They've stabilised, now repeating every 13.701 minutes with machine-like regularity. The amplitude is constant, the phase locked to the planet's rotation, the field is humming, and no one knows why. A report leaked from NASA's Goddard Space Flight Center describes the phenomenon as coherent-induced oscillation, but the data doesn't fit any natural resonance. Jupiter shouldn't hum like this. It's too steady, too deliberate. The simplest explanation is the most unspoken one, that the event left something behind. Not debris, not an artifact, just a pattern. In March 2026, when the shockwave reaches Saturn's outer magnetosphere, the Cassini-2 probe registers the same harmonic pattern. The frequency has stretched slightly, from 13.701 to 14.002 minutes, as if the wave is adapting to each planet's magnetic rhythm. The pattern isn't dissipating, it's propagating, moving outward, planet to planet, like a slow, invisible message crossing the solar system. By then, no one publicly connects it to 3I Atlas. The official records have buried the name. But among the people who know, there's a quiet consensus forming. The object didn't just pass through our system, it tuned it. It left the solar system humming at a frequency that matches the rhythm of hydrogen itself. 1420.405 MHz, the language of the cosmos. If that's true, then the signal never ended. It just changed medium. It moved from transmission to resonance, from sound to structure. The way a note plucked once from a string can keep vibrating through air long after the player has gone. In a small office in Cambridge, Loeb writes one final entry into his private notebook. It isn't a conclusion or a theory, just a single line. They didn't come to speak. They came to calibrate, and beyond Jupiter's orbit, somewhere in the cold between stars, 10 silent travellers continue their journey, unseen, untraceable, but not gone. The void behind them sings in intervals of 47 seconds, a lullaby written in physics and left for anyone who learns to listen. Maybe one day something else will answer. Maybe it already has. But for now, all that remains is the echo, faint, mathematical, and perfectly timed, whispering through the hydrogen sea that fills our universe, the sound of departure, still resonating long after the light has gone, April 2026. 4 months since the disappearance. The story has vanished from headlines, but the data has not. Deep space sensors continue to record irregularities, tiny fluctuations in the background radiation that rise and fall like breath. They occur every 47 seconds. Not strong enough to be called signals, not random enough to be dismissed. The International Data Consortium keeps them buried in encrypted archives labelled atmospheric refraction variants. But among those still watching, the physicists, the engineers, the ones who stayed long after the rest moved on, the pattern has earned a new name, the calibration. The first hint came from an unlikely source, an old probe, Voyager 2, still transmitting weak telemetry from beyond 22 billion kilometres. On March 29th, it registered a brief surge, an uptick in plasma wave amplitude that lasted exactly 47 seconds, repeated 3 times, then faded. The direction of origin matched the same vector 3I Atlas had taken after Jupiter. It couldn't have been coincidence. Voyager's instruments aren't powerful enough to record fine detail, but they measure rhythm, and rhythm is what returned. The signal pattern looked identical to the one first observed in late October 2025, down to the microsecond. Something was still emitting, somewhere beyond the heliopause, the threshold where the sun's influence ends. No one announces this publicly. The findings circulate quietly through private networks, past encoded emails and whispered conference calls. Everyone who studies it agrees on one unsettling conclusion. The pulses are not fading with distance. They are stabilizing, as if locking the system into a new baseline. The solar wind itself now carries a rhythmic density fluctuation. Small, nearly imperceptible, but measurable. Our star, it seems, has been tuned. At first, researchers think it's instrumentation drift. But then, on April 7th, the same rhythm appears in data from the Solar and Heliospheric Observatory, an entirely separate satellite, still inside the Sun's gravitational domain. Two machines, billions of kilometers apart, recording the same periodic voids. The effect is global. The calibration is everywhere. Inside Mission Control, analysts begin running long-term models. They find something even stranger. The periodicity of 47 seconds is not constant, it's subtly shortening. By April 15th, it's 46.9. By April 18th, 46.7. Extrapolated forward, the countdown leads to June 3rd, 2026. At that rate, the rhythm converges on zero, a point of synchronization where the pulse would no longer be periodic, but continuous. In physics, that would mean one thing: resonance, a system perfectly aligned with its own oscillation, vibrating in equilibrium. Resonance is power, it's stability, but it's also control. Governments take the data seriously, but no agency claims responsibility for analysis. The UN's Non-Terrestrial Committee issues a single line in its April memorandum. Monitoring post-event magnetospheric stabilization continues. No public advisory warranted the phrase post-event quietly enters official vocabulary, the way euphemisms always do when science meets fear. Meanwhile, on the outskirts of the scientific world, independent radio operators begin to pick up faint harmonics. Using repurposed SETI dishes and custom software, they isolate background noise from deep space recordings and run the spectra through compression filters. The result is eerie, subsonic hums that pulse in perfect 47-second intervals. When sped up into audible range, they sound like a slow heartbeat wrapped in static. For weeks, no one dares to call it communication. But in late April, one team from Kyoto University overlays the pulses onto planetary magnetic field data and discovers alignment. Each beat coincides with small oscillations in Jupiter's magnetosphere. The pattern is not arbitrary, it's relational, as if the source beyond the heliopause is still connected to Jupiter, still maintaining calibration between the planet and itself, and this is where the theory changes. Perhaps 3i Atlas wasn't a visitor. Perhaps it was a mechanism, a system designed not to observe, but to adjust, to synchronize celestial fields to a shared frequency, one woven into the hydrogen spectrum that defines all matter. If that's true, then what happened on December 6th was not an ending, it was activation. The sky is quiet now, but too precise to be silent. Every satellite reports the same residual hum in its magnetometers, a uniform baseline noise once thought to be cosmic static. It isn't static anymore, it's organized. No one can explain how the effect sustains without input. Energy should dissipate, patterns should decay. Yet the data remains clean, rhythmic, self-correcting, as if something unseen continues to fine-tune it from afar. On April 30th, a final set of readings comes from Voyager 2 before transmission fades again. The probe's aging instruments record one last anomaly, a single narrow-band pulse at 1420.405 MHz, lasting exactly 4.7 seconds, the same duration as the goodbye tone 4 months earlier. The difference now is amplitude, stronger, sharper, closer. It came from ahead of the probe, not behind. Something waiting in the dark beyond the heliopause, responding to the rhythm it left behind. The calibration holds, the solar system hums in unison, and the instruments keep listening, caught between physics and prophecy, wondering whether they are recording the universe settling or beginning again. Because whatever 3i Atlas did out there, it hasn't stopped. It's just continuing somewhere we can't yet see. October 29th, 2025. For months the world has been watching, waiting for this moment, the point of closest approach when 3i Atlas disappears behind the sun. And now that moment has arrived. Every telescope on Earth is blind. Every signal is swallowed in the solar glare. The object, the 9 companions, the strange formation, all are gone from sight. What remains is silence, but it's the kind of silence that hums. The data leading up to this moment leaves us with more questions than answers. A formation of 10 bodies moving as one, power readings that defy known thermodynamics, observations cross-verified by instruments separated by oceans, and a timing so precise, a solar conjunction blackout coinciding with the maneuver window, that even skeptics struggle to call it coincidence. NASA's statements are careful, deliberate, almost scripted. The European Space Agency defers comment, citing post-conjunction verification. Independent observatories, once vocal online, have gone quiet. And in that quiet, a single truth remains. For the next 48 hours, no one can observe what's happening behind that wall of light. Not with telescopes, not with radar, not with anything we've built. This is the narrow margin, the blind passage where we either confirm the impossible or explain it away. When 3i Atlas reemerges from behind the Sun, it will tell us which world we live in. If the object appears where the orbital models predict, the natural theories hold. The fragments, the power readings, the geometry, all become noise, misunderstanding, coincidence. But if it reappears displaced, reconfigured, or accompanied by new signatures, if even one parameter falls outside prediction, then everything changes. Not just astronomy, but our entire sense of isolation in the universe. Because what we've been watching may not be random. It may not even be passive. Each anomaly, each perfect interval, each impossible stability could be a single part of something larger, something coordinated, deliberate, waiting for this very moment of concealment to act unseen. A maneuver hidden behind a star. Until we see what emerges, the story remains suspended between two possibilities. Either nature is stranger than our equations can admit, or someone else has been writing the laws we've been trying to read. The sun will turn, the shadow will end, and when the light shifts, we'll finally know what crossed that invisible threshold. For now, the instruments hold their breath, the sky goes silent, and the line between physics and something else becomes thinner than it has ever been. We stand on that line tonight, the narrow margin between what we know and what is about to reveal itself.